Okay, we are going to do a lesson called, it's section 1.3, and if I put the title up here, it's called Complex Numbers. Now, it's not complex numbers because it's difficult, okay, in that way. There's just a certain set of numbers that we call complex. They give a big explanation in the book, and I thought about going through it about not necessarily why they call it complex numbers, but there are all kinds of different number systems. When you first took math, I guess I am going to talk about it a little bit. When you first took math, you just did like regular numbers, or we learned later on that they were called integers, okay? Right? There was no fractions. It was 1, 2, 3, 4, 5, 6. You could count stuff, counting numbers, sometimes we would call it. Then they threw in negative numbers, right? When you got a little bit older. You're like, when you're a kid, you thought, what, negative numbers? There's no such thing, it doesn't exist, blah, blah, blah. But we know it does, okay? We know that you can use negative numbers. You also used fractions, numbers in between 1 and 2. So if you're counting something, there's 1, 2, 3, 4. Then you get a little bit older. You're like, oh, if I cut 1 in half, I got 1.5 or 2.5, right? So the more and more we progress learning our numbers, there's number systems. We learned about rational numbers, which are fractions. We learned about irrational numbers. Anybody know what an irrational number is? We just finished doing a big section of it. Okay, right? So give me an irrational number. Pi is an irrational number. Very good. There are other numbers. Okay, infinity's really not. So what about a square root, like the square root of 2? If you put the square root of 2 in your calculator, you would get, 1 point, I think it's 2.1 something. I forget what it is off the top of my head. And it would just keep on going forever, and it wouldn't establish a pattern. That's called an irrational number. Okay, so square root of 3, square root of 5, anything that doesn't come out nice and even would be that. So our whole math career, we've learned all these different styles of numbers. Okay, and this is just one more style of number, a complex number. And people look at this in high school and like, well, there's no reason to learn this. I'll never use this. I had a kid come to me a bunch of years ago at my other school and said, my mom said I didn't have to do this homework. I'm like, why did your mom say you didn't have to do this homework? She said, because she said that my mom said she never used this stuff in real life, so I'm never going to have to use this stuff in real life. So she told her own kid that she didn't have to do the homework because she never used this stuff in real life. I was astounded. I didn't have anything to say to that. I was like, well, whatever, you're still going to get marked off for not doing your homework. You're still getting a grade for this class no matter what. So anyway, I'm not going to go and I actually had a guy, I keep saying I'm not going to do this and then I do it. I don't know. I can't help myself. I had a guy come in, again, to my other school. He was a former student of mine. He worked at Boeing, right? They make airplanes. He actually made helicopters. He was actually on the design team to make these Apache helicopters. And I asked him about complex numbers one time. I'm like, man, I said, I'm teaching this stuff, and it's not that hard to do. I said, but do you really use this stuff? He was an engineer. I said, do you really use this stuff? He says, oh, let me tell you, Mr. Hamrick. He says, I use this all the time. You wouldn't believe how much you use complex numbers, and especially in areas like electricity. Like if you're an electrical engineer, that kind of thing, you would use complex numbers. And it's just like a regular number system that we're used to. It's just a little different, okay? So that's my little preface to this lesson, okay? That people do use this stuff that we're going to do right now, okay? We're just learning the very basics, the very, very basics of this stuff, okay? But if you do continue in your math career, there will be a point where you can see how it can be used in real life. We're not really going to do that now, okay, because we're just too basic right now, okay? Of course, it gets a lot more complicated, but people do use this. I had a whole class in college called complex analysis. The whole entire course just dealt with complex numbers. We did algebra with complex numbers. We did trig with complex numbers. We did calculus with complex numbers. There's a whole entire class on this stuff. So it does become very complex, okay, very difficult, but we're just going to do the very, very basics. Let's start with the very first thing. Cameron, what's your question?
I'm going to go to college and do architectural thing and mechanical engineering.
Okay.
So my dad, since he was a mechanic, he said, I'm going to definitely need this.
Yeah. Good. And this can be used. Now, is everybody going to use this in their everyday life? Of course not. Have I ever used this in my everyday life? No, not except for teaching. Okay, I've never used it. It doesn't mean it's not worthwhile to learn. Okay, there's a million things that you're going to learn throughout high school, throughout college, throughout your whole entire life that you may not use in a practical way, but it's very useful to learn this stuff. Okay, so I'm going to talk about this right now, the imaginary unit, or I would just say an imaginary number. And again, that throws people off. They're like, well, wait a minute, if it's imaginary, it doesn't exist. Well, these numbers actually do exist. They don't exist like we understand regular numbers to exist, okay, but they do exist. So it's not imaginary, it's not made up, it's not pretend, all right? That's what we think of when we think of the word imaginary, okay? But they do exist, but they just use the word imaginary. It's probably unfortunate that they use that name, but that's what they call it. And let me show you what it is. So if I did this, we use the letter I to represent a imaginary number, or they say an imaginary unit. Okay, so what I'm going to do with this, though, is I'm going to square it and tell you what it's equal to. So if I have this letter, it's not a variable. You know how you have solve for x, solve for y, solve for a, solve for b? It's not that. It actually stands for something in particular, like pi. Pi is 3.14159, blah, blah, blah. It actually stands for a number. This letter I actually stands for a number. Again, it's not a number that we're used to. It's not on the number line necessarily, on the real number line, but it is a number, okay? So if I square that number, I'm going to get a -1, okay? So I get I squared equals -1. So that's my imaginary unit. So that's super important right there. It's kind of like a definition, all right? So I squared is equal to -1. Now, I'm going to take this one step further. What if I wanted to find out what I is actually equal to? Remember I said I actually stands for an actual number? So what if I want to get I by itself? We've done this. If something is being squared, how do you get rid of something that's being squared? You square root it, that's right. So if I take the square root of this, watch, I'm going to start off with this. So this is by definition. They tell you that I squared is equal to -1. If I wanted to find out what I is actually equal to, then I would take the square root of this, I would take the square root of this. So the square root of I squared is just I, because they cancel out, and then equals, what about this? What have I been telling you all along, especially when we did that square root stuff? You can't have a what inside of a square root? You can't have a negative inside of the square root. And check this out. We have a negative inside the square root. When I said earlier that you can't have a negative inside the square root, that means you cannot get a real answer. Okay, all the numbers we've dealt with, okay, integers, just regular whole numbers, fractions, rational numbers, irrational numbers like pi and like square root of 2 and stuff like that. They are all real numbers, okay? This is a different type of number set, okay? This is called the imaginary numbers. And in the imaginary number set, you are allowed to have negatives inside of the square root. And that's the definition right there. It's from I squared equals -1. They told you that, so you can figure out that I is equal to the square root of -1. So anytime you see the square root of -1, what can you replace it with? I. You replace it with I. Again, I is not a variable. It can't stand for anything. It only stands for one thing, and that's the square root of -1. Does that make any sense a little bit? Okay. What I want to do in here, in a high school math class, I'm not all that concerned that you learn exactly like why you use this stuff, all right? And sometimes it's hard for a high school kid to get their mind around because you want to find out what practical reason does it have. Sometimes in high school, we don't really understand the real practical reason for it. But I can tell you, like I said before, that there are reasons to learn this, that people do use this stuff, okay? In fact, I talked to a guy in my church, and I asked him to come in and talk to my math class about how he uses math. He started his own business. He's like an engineer, and he started a couple different businesses. Pretty nice guy, a really nice guy. And just barely knowing, but I said, hey, would you be interested in coming in my math class and talking to them about how you use math, like in the, quote, real world? He says, oh, I would love to. I would love to. So he gave me his number. I wrote him, told him, and I never heard back from him. So I'm going to have to bug him a little bit more. So hopefully, I would really like him to come in before Christmas, but I would like somebody to come in and talk to you guys about the importance of learning math to do something. Okay. Well, let's just see if this guy will come in. Okay, so that's imaginary numbers. So let's do this. Let's talk about the complex number. Now, the complex number is this. Complex number. It's actually a combination between a real number and an imaginary number. And this is how we write it. And we call this the standard form. Okay, so this is written in standard form. All right, put a little thing right there. So it's A plus B I. That's it right there. That's really important. Let's put a box around that. Put box around important stuff. So that's considered to be an imaginary number. I'm sorry, a complex number which has two parts to it. Let's get out of that. There we go. It's got a real part. So that A is the real part. And then you have this B, which is the imaginary part. Okay? So you got two parts to it, a complex number. You remember in English class when you did grammar? I don't even know if you do grammar anymore as a senior, but remember you did like complex sentences? Do you remember that? Wasn't a complex sentence, if I remember right. I haven't had high school English since 1983, I think, probably. So that's a long time ago. But a complex sentence, isn't it a combination between like a simple sentence and a compound sentence, or two simple sentences, or two compounds, or something like that? Anybody remember their grammar? What was a complex sentence? Did you ever learn that? What was a complex sentence? Wasn't it a combination between two?
It's like a combination between two simple sentences.
Two simple? Okay. Okay, yeah, it was between two simple sentences. Well, a complex number is kind of the same thing. It doesn't mean it's any harder. Okay, so forget that word complex as far as, oh man, that must mean this is really difficult. It's really not. Once you learn how to do this stuff, it's actually pretty easy. It's just the words, are not the greatest right here, complex. But anyway, it's a combination between a real number and an imaginary number. So this isn't two numbers. This whole thing in that box right there is one number. But what kind of number is it? It's a what? Complex number. Okay? So it looks like there are two things being added up, and it's true. You could even have two things that are being subtracted. Okay? It could be A minus BI. You could have a plus or a minus in here. Okay? But that would be considered a complex number. This whole thing is considered to be one number. Okay? All right. Enough of that. Let's do some stuff with this complex number. All right? So let's push that up a little bit. Yeah. Yeah, go ahead. No, go ahead. All right, let's try it again. Let's do that. So let's do some arithmetic. Okay, some basic arithmetic with complex numbers. Okay, you know how to add regular stuff. Remember when you're a little kid, you learn how to add stuff like that. We're going to basically do the same thing, except these are real numbers. We're going to learn how to add complex numbers. Okay, so here we go. So if I was to add A plus BI, okay, that's again one number, one complex number. And if I was going to add it to this, C plus DI, this is how you would add them. You basically add them just like they're like terms, just like you did when it was regular algebra stuff. So look at the numbers that don't have an I with it. That would be the A and the C. So you add those two things together. So it's A plus C. All right, we'll put that in parentheses for right now. And then you're going to add up the things with the I's. You got a BI plus a DI. You can't really combine them, but you could do this. Let's do this. I'm going to put a step that they didn't put in here. You could do that, but let's make it look a little prettier. So A plus C plus, what could you do with this? You could factor out an I, couldn't you? But we always put the I on the right-hand side, and then what's left inside of there? B plus D. So you could do it like that. So this is what the book has. The book has this thing right there. The same thing works with subtraction. So let's do subtraction. So instead of plus c plus di, we're going to go minus. So I'm going to go a plus bi, put a minus, put a c plus di, and let's see what we get there. So again, let's remember this is being distributed, okay, just like it was regular old algebra stuff. All right, so it's going to be a minus c this time. Okay, and then what we're going to do is we're going to put a plus here for a reason. I'm going to show you why. Now right here, what do we have? We have bi minus di. So what we're going to have, we have bi minus di. Okay. Would you agree that that's the same thing, right? Because a positive di and then a minus di, yeah? And now what we can do this. We could go a minus c. And then what we're going to do is factor out the I. We're going to put it on the right-hand side because we always put the I on the right, not on the left. So it's b minus d. So that is how you subtract. So let's do an actual example. It's kind of boring just with black and white. Let's go yellow on this one. So example 1, and this is part A. So I'll show you how easy it is. All that to say this. I probably could have just started the whole lesson by just doing this example, but that's okay. You got to know what that I represents and all that kind of stuff. So I think it's important to do what we just did. So let's go through this. See this little part with the I on the outside? To tell you the truth, I really don't do that much. Usually this right here is how I add those up. So let's do this. Let's add some like terms. Basically, pretend the I was like an x. If this was 5x and 3x, and you were to add these up, you'd do it the same exact way, except it's an I. But it's not a variable. Remember, it stands for an actual number. So what are we going to do? Add up the regular numbers first. Add up the integers. So 3 plus negative 2, or 3 minus 2, right? I'll just write it out so in case you get confused. All right, so we go 3 plus negative 2. Plus, now let's add the i's. So we got a 5i plus a 3i. Now, very quickly, you should be able to figure out that you could probably go from this step to the next step in your head instead of doing this. But I'm just doing this step right here just to make sure you don't get confused. All right? So I added up my like terms. This is not distributive property. This is not FOIL method. I'm just adding like terms. Don't be fooled by those parentheses. Okay? There's a plus in between. It's not FOIL method. You're just adding like terms. So 3 plus negative 2, that's a 1. Okay, plus, and then 5i plus 3i is 8i, so that goes right there. And then that's your answer. It's all you do. It's pretty easy, isn't it? Just add like terms. That's all it is. It's basic Algebra 1 stuff, really pre-algebra stuff, except that I is a little bit different, and it actually stands for something. So let's try another one. 6 plus 4i. They just put them in parentheses just to group them for right now, just so that you can understand the complex number thing. So this is one complex number minus another complex number. But we're going to only add the parts. Add the real parts together, add the imaginary parts together. So let's see what we do. We got 6. Remember, this is a minus, so this minus is being distributed through both of these things right here. So it's going to be 6 minus 3. So we're going to add those up. And then we got a 4i. I'm sorry, let's put a plus in between. And then we have 4i minus what? 6i. Whoop, forgot the I. So that's how we add them up. We just add the like terms. 6 minus 3 is 3. What's this? 4 minus 6 is negative 2, plus a negative 2 is just minus 2, and then you got the I, so don't forget the I, so it's 3 minus 2i. And that's it. That's how you add them up. And subtract. So we added and we subtracted. So what do you think is next? We added, we subtracted. What do you think the next thing? Multiply. That's good. So that's what we're going to do. So now let's multiply complex numbers. All right, so we're going to multiply now. So they start right off with an example. They don't do that a plus bi stuff. They just start off with an example. This is example 2. Let's scroll that up a little bit. All right, now it is important that you have the parentheses on this because there's not going to be a plus or a minus in between. If there's no plus or minus in between the parentheses, what does that automatically tell you you're doing? You're multiplying, okay? You're multiplying these together. Now, this is, remember I said before it was not a distributive property, it wasn't FOIL method, but now on this one, this is FOIL method. So we're going to do a little FOIL method. All right, remember, first outside, inside, last. We've done a lot of that, so you should be used to it by now. So the first, let's just do this in our head, okay, instead of putting 5 times 2. I don't think we need that. So we go 5 times 2, which is 10, all right? And then that's the first. Then the outside is plus 5 times 7i. You multiply it just like it was a variable. Even though I is not a variable, I've said this a lot already, I'll probably keep saying it, even though I is not a variable, we multiply and we add them together as if it was a variable, all right? So 5 times 7i is 35i. Let's do the inside. 3i times 2 is 6i. Very good. And then we do this. 3i times 7i. So 3 times 7 is 21. What's I times I? It's I squared. But do you remember the very first thing we wrote down today? Look in your notes. I squared is -1, isn't it? Okay, we're going to do that in the next step. But understand that whenever you see an I squared, excuse me, is actually equal to -1. All right, so let's make sure that we understand that. So let's add some like terms. I'm going to keep the 10 there for a second. We're going to change that in a little bit. But here's my like terms so far, is this 35i plus 6i. So we add those up, and that's 41i. And then I'm going to write this. I'm going to write plus. I'll tell you what, let's do this off to the side, because this is kind of like in my head. See this blob right there? That's my brain, all right? So inside of here is 21 times I squared. What's I squared? -1. So what's 21 times -1? What's 21 times -1? Come on, you guys are scaring me. It's -21. That's right, it's just -21. So you should be able to go from here to here in your head. All right? If not, I showed you what you had to do. All right? So again, very, very soon, very quickly, even on the next one, you should be able to see 21 times I squared is -21. We good? Okay. So let's add some like terms and we'll be done. 10 minus 21. 10 minus 21 is -11. And then you can't do anything with that 41i. You just keep it like that, and there you go. So we took two complex numbers, multiplied them together, and we got a complex number. And that's your answer. You leave it like that. You can't do anything else with it. Okay, that is a number. It's one number. It's a complex number. All right, right there. What do you think?
My brain hurts.
Why? Confusing.
I mean, I get it.
The only thing different, look, the only thing different that we did today, the only thing, I promise, the only thing we've done different than regular Algebra 1 is this I squared. We just changed that I squared to a -1, multiplied it by 21, and got a -21. That was really the only thing different. What if I would have had 5 plus 3x times 2, plus 7x, right? What if I gave this to you? You could have done that very easily, right? That wouldn't have been a problem. So this is not any different. This is no different until you get to that I thing, until you get to that I squared. Change the I squared to a -1, multiply it by this 21, and then you get this. So really, it's no different than your basic Algebra 1 stuff. It really isn't. I'm not just saying that just because I'm the teacher. It truly is the same thing as doing just regular old algebra, except when you get to the I squared. All right, let me introduce another number or another word to you, and that's called the conjugate. Again, conjugate or conjugate, okay? Conjugate would be a verb, right? You did that in English class, right? We're going back to English today. All right, you go back to English class, you had to conjugate verbs, or Spanish class, right? We're in a Spanish classroom right now. Then you have to conjugate verbs when you're in Spanish. I hated that, didn't you? Like, what is it? Ser and what's the other one? Sar? A star, right? Ser and a star, that's what it was. And I could never get those straight, okay? I think now if I took a Spanish class, I might understand it a little bit better. But back when I was in high school, I couldn't get it. But anyway, but that's different. That's different. This is just called a conjugate. Without going through a lot of stuff that the book goes through, I'm just going to show you how to do a conjugate. All right. So if I had a plus b, I, that's just a regular complex number. If I asked you to find the conjugate, okay, I'll just put conj for conjugate. I'm going to show you how they do it, but I'm going to do this first. If I said, find the conjugate of a plus bi, watch how easy it is. It looks like it's going to be confusing because you got that crazy word conjugate, which you've never seen in a math context, but it's super, super easy. Do you see that plus, that sign in between those two numbers? All you do is change the sign. That's all you do to find the conjugate. So if I asked you to find the conjugate of a plus bi, what would it be? A minus bi. That's it. I told you it was easy, didn't I? Okay, to find the conjugate, it's super easy. What if I gave it, what if I said, let's do it, put some numbers in here. What if I said 3 minus 2i? And then I said, what is the conjugate? That's not going to be our symbol right there. I just did that. I'll show you the official symbol in a second. Exactly. You just change the sign that's in the middle. All right. The one that's in the middle. That's it. Okay. If this was a -3, you wouldn't change the -3. Only change the sign that's in the middle. So this would be 3 plus 2i. Here's the what's the word? This is how the notation, that's what I was looking for. Here's the notation for it. If they said that z is equal to a plus bi, the conjugate is this. I think we did this in college. I can't remember exactly, but I looked in the book. They don't really give you a word to describe this, but I'm going to call it z bar, okay, with a bar on top of it. You with me on that? So I'll just call this z bar, which means it's the conjugate. That's the notation that the math book is using to represent the conjugate. So instead of writing this stuff right there, okay, they're going to say, what is the conjugate? So if z is a plus bi, what's the conjugate of z? We already did it once. It's a minus bi. You with me on that? That's what that means right there. This just means it's the conjugate of z whenever we put that b on the top of there. We good with that so far? So now, let's do an example. And I want to show you why we're going to do the conjugate. You're probably thinking, well, big deal. Okay, I know what the conjugate is, but how are you going to use it? Well, I'm glad you asked because we're about to do this. So if z, here's an example. This is example 3. Example 3. If z is equal to 3 plus 4i, then you're basically finding z bar, or the conjugate of z. Actually, in this problem, we're not just finding the conjugate, we're actually going to multiply the conjugates, okay? So if z is equal to 3 plus 4i, then z bar is equal to what? What's the conjugate of 3 plus 4i? 3 minus 4i. Very good, we just did it. So that's pretty easy. What they're going to say is they're going to say find this, z times z bar. What does that mean? We're going to take 3 plus 4i, which is the z, and what are we going to do to it? We're going to multiply it by its conjugate. You hear what I just said? We're going to multiply it by its conjugate. That's really important. They're leading you up to something, okay? This is not the end-all, be-all, this little part right here. They're leading you up to something else that we're going to do, okay? So it's z times z bar. So what is the z? 3 plus 4i. I want to show you what's going to happen every time you multiply a complex number by its conjugate. It actually is kind of cool. So what's the conjugate of 3 plus 4i? It's 3 minus 4i. Okay, and they're going to ask you to multiply it right there. See that? They ask you to multiply these together. Well, we just finished learning how to do that, didn't we? So we do a little FOIL method. So first, 3 times 3 is 9. Outside would be what? Negative 12i. Inside would be, oh, look what's happening. You see what's going to happen here? Anybody with me? What happens? They cancel out, don't they? That's always nice. Don't you like when stuff cancels out? Yeah, absolutely. What's the last part? Positive 4 times negative 4 is what? Negative 16. I times I is I squared. Ah, I squared. I know what we do with I squared. What do we do with I squared? It's a negative 1. That's right. So let's see if we can simplify this further. I'm just going to write the 9 down. Again, what happens to the minus 12i plus 12i? They add up to 0. Okay, they cancel out. I'm okay if you say cancel out, but understand what they're doing. They're adding up to 0. Everybody got that? All right, and then let's see if we can do this in our head right here. We said I squared is negative 1, but it's negative 1 times what? Negative 16, right? Because there's a minus in front of it. So what's negative 16 times negative 1? Positive 16. It's just arithmetic. If you wanted to write that step down and put a negative 1 in there for I squared, you could do that. But I think you could do this in your head. And then what's that equal to? 25. So check it out. We took two complex numbers with i's in them, we multiplied them together, and we get a real number. This is not a complex number. This is just an ordinary, everyday 25. All right? But how did we get that? We got it by multiplying a number by its conjugate. So if I gave you a complex number and you needed to find what the you needed to do something to it to get a real number, you would multiply it by its conjugate. So all that said, for this, everything we've done today basically boils down to what we're going to do right now, okay? And that's the way math is. You've seen that all year long, haven't you? You've seen it your whole math career, right? You learn a little bit, and it builds, it builds, it builds until you actually use it for something. And this is what we're going to do, okay? This is example 4. Example 4. And it will say, write 1 over 3 plus 4i. Now, oh my goodness, what are they doing here? Made a fraction with an I in there, okay? But we're going to write this in standard form. You remember what standard form is, right? Somebody just tell me, what's standard form? Say it, I can't hear you. Very good, a plus bi. Standard form is a plus bi. So we want to write this as a plus bi. Now, do you remember what I is equal to? No, it's not negative 1, just I by itself. Not I squared, just I. It's the square root of negative 1. So check this out. I have an I in the denominator. Is that a good thing? No, it's not. Why is it not a good thing to have an I in the denominator? Because it's the square root. That's right. You can't have a square root in the denominator. Remember that? We've talked about that before, just a week ago or two, or something like that. Okay, we talked about that. So you cannot have a square root in the denominator. So you never, ever want to write an answer like this. So that's why they're trying to get you to get rid of the I. That's why they're putting in standard form. Okay, you don't want to ever write your answer like this. So what in the world are we going to do? Well, this is a complex number. How can I turn a complex number, or what can I do to that complex number and turn it into just a real number and get rid of the I? Matt? Plus? You sure? Would that cancel it out? Look at what we just finished doing. Look at the last example. We didn't multiply it by itself because you said 3 plus 4i. What did we multiply it by in order to get rid of the i's? The conjugate. What's the conjugate of 3 plus 4i? 3 minus 4i. Okay, so you're on the right track, but we got to multiply it by the conjugate. Okay, and that's what we're going to do. So I start off with that. In order to get rid of that I want to turn it into a real number. We multiply it by its conjugate, 3 minus 4i. And then, of course, you said it, Matt. What do we do at the top? 3. No. Yeah, you do it by the same thing. Because what's 3 minus 4i over 3 minus 4i? It's a 1. We're allowed to multiply by 1. Hate to say it, but we've talked about that before too, right? In here. I don't hate to say it. That's probably a good thing that we did, right? So all that review stuff is coming back to help us. Not to haunt us, but to help us, all right? I'm going to put this in parentheses because we're going to multiply this through. What about the top? The top is just multiplied by 1, isn't it? So it's just 3 minus 4i, so I don't have to do anything with that. If that was a different number, you'd have to distribute it through this thing right here, okay? But it's not. It's only a 1, so it's 3 minus 4i. What about the bottom? Remember what happens when you multiply by the conjugate. What happens to that outside and inside term? what happens to the outside and inside? They cancel each other out, don't they? Okay? So do we really have to go through that whole routine where we do the outside and inside? Now, you know the outside and inside are going to add up to 0, right? So don't even bother doing that. Just do the first and the last. You understand that? So I'm only going to do the first and the last. It's FOIL, right? First, outside, inside, last. So I'm going to, you know the outside and inside will add up to 0. I'm not even going to worry about doing that. So let's just do the first. 3 times 3 is 9. And let's do the last. Positive 4, negative 4 is negative 16. I times I is I squared. We just finished doing this, didn't we, on that last example? So let's see what we can do with this. 3 minus 4i, that doesn't change on the top. We can do this in our head now. I squared is negative 1. That's negative 16 times negative 1 is positive 16. 16 plus 9 is 25. Can you do this in your head right here? We just did it on the last example, so you could just look at the last example. Okay? Oh, get these twinges in my back. It looks like it's our answer, but is that in standard form? Is that a plus bi? No. You got a fraction. This doesn't have a fraction, right? This doesn't have a denominator. So we want to write this so we don't have a denominator. So here's how we're going to write it. We're just going to split it up into 2 individual fractions. So we're going to go 3 over 25 and then minus, what do you think this is going to be? 4 over what? 25. Nobody's talking, so I'll do all the talking. 4 over 25. And then you're going to put an I on the outside. Would you agree that this is the same as this? Because what if you took this and you wanted to subtract those fractions to each other? What would you do? You find a common denominator, right? It's already got a common denominator, so you put everything over 25. Right here, we're just splitting it up into the 2 fractions with that common denominator. Can you simplify 3 over 25? Nope. Can you simplify 4 over 25? No. If you could reduce your fractions, you must do that, okay? Make sure that you do that. And that's your answer right there. That's in standard form. Even though we have fractions, what's our A on this situation? What's our real number for this answer? 3 over 25. What's our imaginary part to this complex number? 4 over 25, okay? Or negative 4 over 25, okay? And then this is our imaginary number right here. So it's got a real part and it's got an imaginary part, and it's got the I right there. So that is a complex number. So we took that and we put it into standard form. Okay, I am going to skip the next one. I'm going to skip example 5 just due to time. Okay, so you can look in the book. It's pretty much just like what we did. Okay, except it doesn't have a 1 on top. It's got something else on top. But you just multiply. If you have questions on that, we can go over that tomorrow. But look at the book. Okay, look at the book for example 5. I'm going to skip example 6 as well. And now what I'm going to do is talk about this. I think I can do this in 5 minutes. We have 5. Oh, we got 10 minutes, don't we? Oh, good. I definitely have time. All right, so powers of I. Watch this. I to the first. I to the first is just equal to I. It's true it equals the square root of negative 1, but I'm just going to write it as I. Everybody's watching? Okay, Renee, you good? Okay. So we've got I squared. Do you remember what I squared is equal to? By definition, it's what? It's negative 1. Very good. Now, let's go a little bit further. Let's go I cubed. In fact, I'm going to take it off to the side over here. Okay, what's I cubed equal to? Well, you could write it as I squared times I. And that's what we're going to do on a lot of these. Okay, we're going to break them down into things that we know. So what is I squared? We know that already. It's negative 1 times what? I. So what do you think I cubed is? What's negative 1 times I? It's just negative I. So these 4, I'm going to write down 4 of them. Okay, these 4 you should have memorized. Okay, I is just I. That's easy to memorize. I squared, that's not too hard, right? Because that was our definition to beginning with, is negative 1. I cubed is probably the one that's the most difficult to remember, but I cubed is negative I. Try to remember that. If you can't remember it, you can go back here, break it down, and figure out that it's negative I. So what about I to the 4th? I'm going to put it up here. I to the fourth. How could I break down I to the fourth? Very easily. Well, that's the same as, yeah, you could do I cubed, but watch this. I squared times I squared, because you're going to go I cubed times I, right? Which would be fine, but this is going to be a lot easier. So what's I squared? -1. What's this I squared? -1. What's -1 times -1? +1. So what's I to the fourth? +1. If you can memorize these, you can do all the questions that they are asking you to do. So let's go a little bit further. Let's change colors. What's the next one? Oops, I thought I changed colors. Doesn't really matter. There we go. What about I to the, what's the next one? To the fifth. How could we break down I to the fifth? Well, I to the fifth, what's the biggest one that we know off the top of our head? I to the fourth, right? Okay, so I would try, if you could break these down into I to the fourths, I would always do that. So you know what I to the fourth is? That's easy. It's just 1. So what's I to the fifth? I to the fourth times what? I. So what's I to the fourth? 1. What's I to the first? Just I. So what's that equal to? I. Do you see how I to the first and I to the fifth are the same thing? Because if we break them down, we're just taking out an I to the fourth, right? What are you left with? An I right there. See what we're doing? We're going to be doing this with bigger numbers, though. All right? I'm going to show you something. So I to the 6, let's go a little quicker. So I to the 6 is the same as what? Whoops, gave it away. I to the fourth times what? I to the second, right. Because I know what I to the fourth is. What's I to the fourth? 1. What's I to the second, or I squared? -1. What's 1 times -1? It's -1. Isn't that the same as I squared? Yep. See what you did? It's not really factoring, but kind of is. I guess it is. You pulled out an I to the fourth, didn't you? What are you left with? An I squared. What's I squared? It's -1. Let's do the same thing with I to the what? 7th. So take out a what? I to the fourth. So what are we left with? An I cubed. What's I to the fourth? It's a 1. What's I cubed? It's a -I. What's 1 times -I? It's just -I. It's the same thing as I to the third. Easy, right? Told you it's easy. I wasn't lying, was I? What about I to the 8th? I to the fourth times what? I to the fourth. Good. What's I to the fourth? 1. What's another I to the fourth? 1. What's 1 times 1? It's 1. So check this out. I to the fourth is 1. I to the 8th is 1. So what do you think? What do you think I to the 12th is equal to? I to the 12th. It's a 1. Why? Because it's a multiple of 4, isn't it? Anytime you have an exponent with a multiple of 4, what's that going to be? It's going to be a 1. Okay? What's I to the 20th? It's not I. It's 1. Why is it 1? Because 20 is a multiple of 4. So I could break those down into 5 I to the 4ths, couldn't I? You with me on that? Okay, and so it'd be 1 times 1 times 5 times is just a 1. Anytime you have an exponent with a multiple of 4 with the I, your answer is 1. What if you had this, though? What if you had I to the 37th? Well, 37 is not a multiple of 4, but what's the biggest number that's close to 37 that's a multiple of 4? 20? There's a lot more numbers that are multiple of 4 that are close to 37. 36, very good. I to the 36 is a multiple of 4, and it's really close to 37, isn't it? But what is I to the 37th? It's I to the 36 times I to the what? First, or just I. Would you agree? That's I to the 37th. What's I to the 36th? It's 1 times I to the first. So I to the 37th is just an I. You get me? Let's do another one. So that's kind of fun, huh? Let's do one more. Then we got, let's not do another one. That's good enough for that. Okay, let's do example 8. Sorry, I can't answer questions right now because of time. I don't know if we'll be able to finish this. It says, write this in standard form. 2 plus I cubed. All right, let me show you real quick, okay? You can always go back. I'll go fast, okay? But you can always go back and watch the video. They do it, in the book, they do it a certain way. I'm going to do it a little bit different because I don't think you remembered what something cubed is. But anyway, let's just do this. So what's cubed? 2 plus I times what? 2 plus I times 2 plus I. Okay? Watch what we're going to do. I'm going to take this and figure out what that is first. I'm just going to tag the 2 plus I along. Let's do some FOIL on this. Let's do it really quick here. 2 times 2 is 4, plus 2I plus 2I is 4I plus I squared. Okay? That's 2 plus I. Let's do a little bit of this in our head. What's I squared going to be? Negative 1. 4 minus 1 is 3 plus 4I. You with me? So that's what 2 plus I times 2 plus I is. Now we multiply it by another 2 plus I because we're cubing the thing. And now we just do the same thing. We just do FOIL again. 2 times 3 is 6. Outside, let's do it together. Outside is 8I. Inside is 3I. What's 8I plus 3I? 11I plus what? 4I squared. 4I squared is the same thing as negative 4. 6 minus 4 is 2 plus 11I. Do you get that? Are you laughing because you didn't have any idea what I just did, or because you got what? Oh, you got it wrong? So anyway, that's how you do it right there. Make sense? All right, go back and watch. Try it yourself. All right, and you can see how to do that. All I did was I just cubed it, right? So I multiplied these. That's a FOIL method. I just did FOIL method twice, basically. All right, that's all that was. You okay with the I stuff? Here's your homework. You're doing section 1-3, part 1, which is pages 116 and 117. And you are doing numbers 9 to 45. Looks like a lot, but it's just the odds, so it's not that bad. If you guys came in late, I have the lesson plan sheet for you, so make sure you come by and get that. Okay?